globe is absolute bollocks. And you're just a stupid fucking bunch of knobs. The globe is absolute bollocks. And you're just a stupid fucking bunch of knobs. The globe is absolute bollocks. And you're just a stupid fucking bunch of knobs. The globe is absolute bollocks. And you're just a stupid fucking bunch of knobs. The globe is absolute bollocks. And you're just a stupid fucking bunch of knobs. The globe is absolute bollocks. And you're just a stupid fucking bunch of knobs. The globe is absolute bollocks. And you're just a stupid fucking bunch of knobs. The globe is absolute bollocks. And you're just a stupid fucking bunch of knobs.
Keep up the good work, man, and stay flat, okay?
Okay, I'm a flat earther.
Well, oh, wow.
What's up, heathens? How y'all doing?
I just wasn't expecting. I wasn't expecting to come on with such excitement from you, GE. I like it. Welcome everybody to the show. Tonight we have Rhetoric. Hello, sir. Oh, he's in a good mood. Excellent. And David, you're coming back. I believe this is your second time with us, right? I think you might be.
Yes, that's correct. The second time.
Perfect. Well, welcome back. We're going to get to introducing you guys officially. GE will do that here in just a second. I wanted to, unfortunately, I hate doing this, but we're gonna have to start with some pretty infuriating news, just because it has to do with something that's going to take place tomorrow. If any of you follow Twitter, then you already know what I'm about to talk about. And if you don't, then good for you. Don't start, because Twitter is the place where all good conversation goes to die. But this morning, I was speaking with Mr. Atheist, and he sent me a screenshot of something that just has really kind of, for lack of a better word, fucked me up all day. And it's because when this happens, I don't expect it from the source that it happened from. I expect it when and we're going to be talking about the whole homosexual thing. I expect it from theists or people who believe in the Bible because of where it comes from. I expect that. I expect that this sort of bigotry comes from that place. I expect that. I don't expect it to come from people who also consider themselves atheist, humanist, seems to fight for everything that we do. This place, this level of just hatred and bigotry is just oddly placed, and it really kind of hit home. It hurt, honestly, because I've had this individual on the show when he started a show with two other people, and we talked about he is of a he's a black guy, and we talked about the persecution that he feels. We talked about that. Like we talked about how that affected him, and how it was and how it was an adjustment, and especially with him being an atheist. And I remember, wanting to push that out there and get that out there, that he shouldn't feel this way. And so, just to be hit with this today, it was a really big slap in the face. But I'm going to read off a couple of screenshots, and then it's going to come down to, he's coming here tomorrow. He and I are going to have a little powwow, and see if we can't straighten this out. No pun intended. But let me read off what the first tweet is. Dave, if you'll throw it up there on the screen. He starts out with let me make this clear. I do not condone homosexuality. If you have an issue with that, you can unfriend me. I'm not here to advocate your sexual views. Okay, just as a brief starting out, there's nothing for you to condone. It's like me saying I don't condone straight. I don't condone heterosexuality. It doesn't make any sense. There's nothing for you to condone there. So that's just really stupid. Okay, the next one, Dave. This one here is the one that really hit it. So he's talking to another individual, and they say, so in your mind, it's cool to have an 11-year-old around grown gay men. Really? Really? Go to the next one, Dave.
I mean, it's horrible to hear that kind of shit coming out of anybody's mouth.
So in my anger, I tweeted out, let me make this clear. Fuck you, Emperor Atheist. To which he replied, fuck you too, since you couldn't text me about it. You know me. I don't give a shit about your emotional rants. Everyone knows I don't hate gays. My daughter is a part of the LGBTQ community. So get your emotions in check, because you wouldn't say that to my face. Number one, if you were anywhere near my face, I would absolutely say it to your fucking face. And number two, the fact that you said that, you make those comments with your daughter being a member of that community, is absolutely disgusting and just distasteful. You should be ashamed of yourself for saying those things when your daughter's a part of that community. All right, Dave, I've got 3 more, and then we're going to move on. But I just need to get this out because I'm heated. I responded, I don't have a fucking thing to say to you, you bigoted, ignorant piece of shit. Get fucked. To which he replied, I don't do Twitter wars. Call me if you got the guts. Then you can take me. Then you can't take me out of context. I leave that weak shit for weaklings. To which I said, you don't do Twitter wars. Oh, I guess posting about it on Facebook is what real men do. You don't have shit to say because your bitch ass got called out for being a bigot. Nobody cares enough to call you. Deal with it. And then the last one is where he calls me a bitch, and then I say, well, why don't you come here and let's see if we can't sort this out. So if you have if this is something, I want you to come here and say this to my face, is what it is. I know there are going to be people who are asking me, why would I even enter into a conversation with this person? Because this is somebody that I consider to be a friend, somebody that I put out there, somebody that I championed and really rallied behind. And I want them to come here, and I want them to say it to my fucking face. And then I will do what I need to do and say what I need to say, but I want that to be said to my face after I called him a friend. And so this is something that I just need to do for myself. So Emperor Atheist, you might you might come into the stream tomorrow as an emperor, but I guarantee you that this queen is going to kick you the fuck off of that throne by the time we're done. All right. Now, let's get into the shape of the planet. GE.
All right, heathens. Well, tonight we have a discussion between Red's Rhetoric, your favorite plumber from the Mushroom Kingdom, and David, who's a guy who has researched things. So, if you guys will have a very nice conversation. I'm not sure who wants to start out with what. We didn't really discuss that prior to the show. Just don't interrupt each other, and we'll have a good time.
Lovely. Okay, let's take a second and go ahead and introduce yourself, David. Let everybody know who you are if they haven't seen you on the last time, and what your channel is about, and just sort of a brief introduction about yourself.
Yeah, Gala said, I'm just a regular guy. I've studied a lot of this stuff. I've researched a lot of this stuff. When I speak, I'm probably going to speak in layman's terms because I really don't know a lot of the scientific terms, but I know what I'm talking about. I've been studying like about 4 years, and I just want to go over the main points and I want to basically keep it simple because it's really not that hard. You don't need to be some college educated person to understand that the earth that we live on is flat. It is, and that's what I want to go over. I could start right now, or you guys want to introduce himself?
Yeah, let's let Red say a little something or another. Reds, my man.
Sup?
What's up?
Yeah. Okay. I'm Rhetoric. You may know me for making very shocking statements, like calling the flat earth theory a crock of shit, and that those who believe in it are either intellectually dishonest or don't know as much as they claim. Recently, I posted a video of the Falcon Heavy launch. I just want to thank everyone for watching that. Because of your guys' support and viewership, we are only 40,000 views away from a 1 million view video. So it's really nice to see people getting interested in space and space travel. And it's just epic that I could bring at least the feeling of being there to your guys' bedrooms in a non-creepy way. So thank you very much for the support. And also, thank you very much, Kyle and Godless, for inviting me on here today.
Our pleasure. Okay, David, please take us away in what you think the reasons that we live on a flat Earth are.
All right. So can I go to the slideshow and I was let's see at number 4. I'll start out with number 4. All right, so this is where I'll start out. Just a bit general concepts of why the Earth is flat and why I think it's flat, and the simple stuff is that there has been no measurable curvature on anywhere in the world, and then of course water makes everything level. Water is level on all the oceans. We don't see any curvature on the oceans, and then the world is covered with about 71% with water, right? So, and if it's all flat, then basically the world is flat, right? The Earth is flat, and then the second thing is that the Earth is stationary. There has been no scientific experiment that shows the Earth to be moving. What we see moving, we see the lights in the sky or the celestial bodies. We see those moving, and not the Earth. There's like I said, there's no scientific experiment that shows this. And then last thing I wanted to talk about was gravity. Gravity, I don't think it's a force like how I like to hear a lot of you guys explain it as there's going to be attracting mass, but I don't think it's relied on mass. I think it's a electrical charge, and I want to discuss that, basically telling you that why it's not mass. Well, it's not the mass attracting mass like it's said to be. And so as far as the first one goes, we'll go over the if you go to, let's see, the next page.
David, your connection's kind of choppy.
Okay.
You're going in and out a little bit. You might want to move closer to a route or something, because it's we're starting to get choppy connection.
All right. Let me see what I could do.
That sounds a little bit better.
Okay. All right. So the first slideshow is we're talking about how what we observe is the Earth to be flat, and just going over examples around the world. There's just a few examples where we talk about the let's see, the Monterey Bay. I have a link right there. They did a test, showing the Monterey Bay it was 13 miles distance, and we see the other side, and that was done with the with a mirror reflection, and so being that we see it on the side, it can't be anything else, which is good that we've done it with the mirror, because if you see it across the water, there's no refraction that could distort it, or any other excuse that is used to say it's distorted or it moves or it bends with when you use the mirror. And same thing with the Salton Sea. Salton Sea was done same thing with the mirror. That one was on 9.7 miles. We didn't see no curvature. Let's see what, and then the first one was which I discussed here last time, and I didn't see, there was said to be something that refuted it, but I didn't see anything that refuted it. But it was talking about the microwave transmission. It's in the Mediterranean Sea, and what they did, it's supposed to be a record where the longest microwave transmission from in the Mediterranean Sea. I believe it was 146 miles that they had contact, and microwave transmissions need to have, like, if something in the way, you wouldn't be able to reach it, like, so there's 146 miles with no disturbance. And those are the main points for the Earth being flat. And then like I said earlier, go ahead.
Oh, no. Did you have anything else that you wanted to say there before we go to Reds?
Yeah, well, we can stay with the one first.
Okay. Reds?
Yes. All right. So I guess it's my turn now.
It would appear so.
Yep.
Okay. Dave, please look at your Hangouts and click on the first link that I sent you. And when you have it up, please go to 1 minute, 20 seconds. Let me know when it's up.
You look lovely tonight, by the way.
Perfect. All right. So what you're seeing here is Tampa Bay. And David, if you could please mute the audio and hit play, I'll describe what's going on. What I did was I went to the north side of the Skyway Bridge across Tampa Bay, and I took this image with the Nikon P1000, the flat earther camera of choice. And as you can see, half of the buildings, which is around 300 feet of the buildings, are disappeared behind a gigantic hump of water, i.e. curvature. This curvature was also modeled against a computer rendering, which will be uploaded on my channel later on, showing that the amount of curvature that we see in this image comports with the round Earth model, having a radius of around 3,959 miles. So despite the claim that there is no observable curvature, I give you observable curvature, again, filmed with the Nikon P1000, the flat earther camera of choice. And so here, I mark the top of the towers as well as the horizon and blink between the two images, one taken close up, one taken further away, 24 miles away to be exact. And here you can kind of see where the water starts cutting off the buildings, as you can see in the image. So yes, there is observable curvature. I'm not going to go into what Soundly has been able to show on Lake Pontchartrain, as well as many other big, large bodies of water throughout the world. But for that, Dave, I would like for you to click on the third link that I sent you and let me know when it is up. That will go over the next point.
It's up now.
Okay. So mute the audio and hit play. This is Bob Nodal from Globebusters. He was actually going over his little observation with a ring laser gyro. And when he turned on this ring laser gyro, he was able to detect a drift of around 15 degrees per hour. Now, they tried to do many things to make it not read that. For example, covering it in crystals or mirrors or whatever to shield it from the heavenly energies, whatever the fuck that means. And the results stayed exactly the same. So we were actually, well, not we, flat earthers were actually able to detect the rotation of the Earth. But when it came down to actually providing this information out to the masses, they withheld the information. They withheld the information from the producer of this documentary, which is Behind the Curve. Recommend you all go watch it. It allows flat earthers to hang themselves with their own rope. And he says, what I told you is confidential. If this got out, it would be bad. His exact words, not mine. And yet, we didn't get it till this documentary came out. So basically what you're seeing here is a direct example of confirmation bias. So we have evidence of curvature, which I was able to determine. We have evidence of rotation, which other flat earthers were able to figure out and discover for themselves. And finally, we also have Greater Sapien responding to the final point, which was the mirror reflection test. Dave, all good from here. So no video for this one. I'm just going to say that Greater Sapien actually responded to the flat earth mirror test. And while flat earthers like to say that that test would not be influenced by the atmosphere, unfortunately, light is light and the atmosphere doesn't care. All light can get refracted. And on the certain test I believe that we're speaking about, the source of that light would actually be halfway up a hill, not at the shoreline, even though when they initially set that light towards the observer, they were at the shoreline. This shows that the light source, the light itself, as it was traveling, was indeed refracted, and it was refracted over a curve. The only way that that light source was actually to be able to be seen was, according to the observer's viewpoint, for it to look like it was halfway up a hill. So refraction is always at play. The only way that you can make sure that refraction is not play is to cherry pick the days, extremely well. And unfortunately, flat earthers have not been very good at doing that. So those are the first 3 points. Let's see what else we can get into.
Okay, David, how would you respond to what you've seen?
Yeah, for the first one, he was saying observable curvature, but I was talking about measurable curvature. We've seen that anywhere. I mean, a lot of times we see a lot of different things, and just to see that is not really doesn't really say much. I mean, I want to see measurable curvature, because like a lot of times people say, oh, they see plane. We know they don't see that, and they say they see curvature all over, but their eyes are deceiving them, I guess. But I want to see measurable curvature to actually know that there's a curvature. But be measurable, that will give us some quantifiable evidence that'll show the measurement, show that it is curvature. And then the one that you did. I don't know the height of that. I don't know how high it was, because what ends up coming into play with that one is going to be your the angle. Was it the angle? I'm not sure the exact term, but it's the angle that you perceive, because it goes at an angle with your sight, your vision, the angle of your vision. It ends up converging. It comes in the floor, and then the bottom is going to converge at one point. And where it converges that's where the water's coming up. So it really determines on your height and how high you are, of course. And but that's for that one. And then as far as the what is it, Behind the Curve, that movie that you were talking about? I mean, it's an edited version of what happened. I mean, if you want to believe movies, I could show you hundreds of movies that the same guy that you right now said that movie that he showed things. How could you gonna believe one movie instead of these other videos that he's done? I mean, why don't you take those into consideration also? I mean, it's the same person, same thing. Or you just give you one example compared to the hundreds that you just shared to. And then
David, hold on one
Yes.
second, David. David, take a breath for a second, because your audio is choppy. I think I know why. Dave, can you take off his noise gate, since he's going to mute when he's not talking?
I've been steadily taking that down as he talks.
Yeah,
just take it. Really getting.
Just take it down all the way.
I'll take it off. Yeah. Just make sure you mute David when you're not talking, because we will get an echo if you have no noise gate.
Yeah. I think it's the noise gate that's doing that. Okay, so the third point was the mirror test.
The mirror test. You're talking about it being refracted. You know what? I'm not too sure. The way I understand it is that there is no refraction, but I mean, as you say, it's different. I mean, I gotta actually say for myself and look into that more. But I mean, I don't think there's any refraction going on or anything going on right there. That's what I think. But I mean, you haven't convinced me that that is.
Okay, Reds, what do you have to say about what David said?
Before Red starts, Dave, do me one more thing. Hit the refresh button on your browser. That'll bring you back in the call because you're still coming in a little choppy. Or is that just me? G, is he sound a little choppy to you?
No, he's pretty choppy for me too.
Okay, yeah, hit the refresh button, David, to come back in. Okay, Reds.
Do I wait for him to come back in so he can hear what I say, or just go for it?
Yeah, but he should be back. He should be back now.
Refresh right now.
Okay, yeah, go ahead, Reds.
Okay, cool. You said a measurable curvature. The curvature that I showed you is measurable. Not only did I show it to you, but I measured it, as I said. And the way that we measure it is because we have a visual reference. Those visual reference are the buildings in question. The height of those buildings is known. Curvature calculations, such as square root of r plus x to the second minus r to the second, is also known. You can apply those values to see if what you're seeing is actually legit according to the round earth model. So not only are you seeing curvature, you can measure curvature. And as I said previously, there will be a 3D model being made of my observation to show how my observations comport with the round earth model. Not only that, but you also have equatorial telescope mounts that will not work unless it's on a sphere, and on the sphere the correct size. For example, if you travel a certain number of miles directly north from a starting point, it will correspond perfectly to a certain amount of angle that you will have to tilt your telescope in order to align it with Polaris. Go south a certain number of miles from a certain starting point, and once again, those angles are going to correspond accordingly. If you're at the North Pole, you will have to point the axis straight up. If you're at the equator, it would have to be looking directly at the horizon. That amount of distance with that amount of angle change will actually give you the entire circumference of the Earth. So the curvature is measurable. It has been measured. It's going to continue to be measured so long as people keep using equatorial telescope mounts. And my observation can be used as a measurement because we have a visual reference where those scales are actually known beforehand. Now, as far as the Bob thing goes, yes, Bob has said a lot of things, and a lot of things that have already been debunked. The reason why we're pointing this one out in particular is because it goes in direct contradiction to what he's been saying this entire time. He said we have never seen any evidence of rotation. We bought this gyro and, no evidence of rotation. And here we have him admitting that they saw evidence of rotation but chose to withhold that information. So basically, Bob Nodal operates on confirmation bias. And when he decided to actually come out and show it, it wasn't until after this documentary was already out that then we finally got some intellectual honesty out of the guy. So yes, we have measurable instances of curvature. We have measurable instances of rotation, which were discovered by flat earthers, not globe earthers, but flat earthers. They just chose to withhold it because, obvious reasons. And you said that you need to study more about the flat earth mirror thing, so I'm just going to let that one go so we can move on.
Okay. David?
Yeah, a couple things. You said, that there's measurable curvature right there on your picture that you but I mean, that's just one location, and I've listed at least four or five different areas in different parts of the world that we don't see any curvature, and I have tons more too. I just wanted to just throw a few out there, but I mean that's we're talking about the whole world. According to you guys say it's big and it's huge and all this stuff, but you're showing one location, which really doesn't really say much. And then second is I mean, the whole Bob thing. I don't know, man. I mean, I don't really consider it's not really a scientific experiment, or then that's what I asked for, scientific experiment. But if you think you don't think so, because according to what he said, and he didn't, and you kind of saw he said that he was holding stuff back, and then he showed it after. I mean, that's kind of contradictory. He did hold it back until a certain time, but they did release it, and I mean, you said that he was holding it back, and then he released it, or he said he didn't want to show it, but then he did. So you kind of contradicted yourself right there. But I mean, they did actually come out with whatever they had, and they explained exactly why they got that information, and it's not according to what you're saying is the movements of right. It's not moving. I mean, we could plainly see that it's not moving. I mean, no matter what type of tools you use or whatever type of gadgets you have, we know that you can't. I mean, you don't feel any movement. We don't see any movement, and we know that it's a star moving up above us. I mean, you're talking about I mean, no, that was something different, but like that's what I know. I could get into more of that as far as the celestial bodies, but I'll move on to the next thing. As far what I really want to go over is what I was talking about is gravity, and let me pull up my slide sheet right now. If we could go to let me pull up the page right here. Okay, so I believe we're at page 7. The next page over, the next one over. Okay, so we have the formula of gravity right there, as described by Newton, and notice it's the same as Coulomb's law, right? And so in essence, that this is what I believe it is, but I think more there's evidence more that suggests it's an electrical charge, because if you look at Newton, according to Newton, that you have the formula right there written out, but there's no reference into time, and time plays a big part in it. But also, if you look over about G, right, they say that G is a constant, but it's really not constant. It's always different when they have whenever they measure it in different locations. It's always comes out to something different. It's not a constant G. If you they say that comets exhibit signs of non-gravitational forces. If you were to measure in skyscrapers, you'll get a different measurement comparing to when you're in a mine shaft. You'll get a different measurement. So the constant G is not constant, and so that can't be used for the formula if it's always changing. And if you go to the next slide over, it's going to get into this in time, about time. Okay, so without the reference to time, what you're saying that time is instantaneous, right? If you don't have it, the formula, right? And so being that it's instantaneous, that would actually lay along the lines of being an electrical force, right? Electrical charge, and because electrical charge it needs instantaneous, it needs to be instant. Comparing to if you're looking at the other way, according to Newton, with the mass, it's not instant. It doesn't happen like that. But you would need to have that included in the formula. Right? If I try to say that formula is what gravity is, right? And so those are different comparing to what I would say it's an electrical force, it's electrical gravity, it's electrical charge, and those are things that are there's a difference comparing the with gravity, right? And so going this route, there's no need to make up things like they have where they make up like dark matter. You don't need any of that stuff, right? And those are all the things that they put in place because they don't have that instantaneous time, right? Like according to what the formula would suggest. And but that's basically the main things that I want to go over. What I'm saying that gravity.
Okay. Before we go to Reds, Dave, I don't know what the deal is, but your connection is still pretty choppy. So here's what we're gonna try now. Look in that control panel where you go to mute and click the click the camera icon. Maybe taking some of the stream off of your what it's taking the camera. We'll put up a picture up there too, like we do for Reds. But let's see in just a second if that fixes, and if that's the case, then we know what it is. Okay, Reds, you want to get into gravity or dropity?
Sure, we'll get into dropity. First, I'm going to respond to something. No, my characterization of Bob Nodal is not something that's contradictory. It's something that has been documented. The reason why you're thinking that there's a contradiction there is because Bob likes to speak out of both sides of his mouth. He says one thing, does another, then does one thing, then says another. And he will often say things that are directly contradictory to one another. The contradiction is not my fault. The contradiction is on his. I simply ask that flat earthers such as Bob at least be consistent. If they are going to provide a observation that completely disagrees with their BS, here's an idea: don't do the observation, because then at least you have an excuse to keep your ignorance alive. That's the only way that this is going to work. But because Bob did this observation, was able to detect that 15 degrees of rotation, that means that the only excuse Bob has now is actual dishonesty. Why is Bob saying what he's saying? Because he's dishonest and everyone can see it. As far as feeling the rotation, imagine you have a clock that's big enough for you to stand on. Now imagine the hour hand on that clock traveling half the speed it normally does, and stand on it. Would you feel yourself moving? No. Let me put it to you another way. Imagine you're on a merry-go-round. Imagine that merry-go-round takes 24 hours to do one trip around. Would you feel like you're moving? No, you wouldn't. Simply appealing to your senses is great for certain things, but for really nitty-gritty scientific measurements, it's not really that well. That's why we have rulers. That's why we have protractors. That's why we have scales. That's why we have, equipment that measures shit with lasers, all right? Because your senses are not perfect. So appealing to them actually shows a significant flaw in your practice of trying to figure out what's going on with reality. Appealing to your senses is going to lead you down the wrong path in some cases, especially when it comes to figuring out the shape of the Earth and whether or not it rotates. As far as gravity and it being electromagnetism, that has been debunked thoroughly, because what we see here is gravity is all about mass. The mass is what gravity is proportional to. If it was about electromagnetism, then I should have a really lightweight, but it be like, let's say, a neodymium magnet, and it should provide me a much different value for the G variable. But when I compare it to, like, let's say, a sphere of lead, the sphere of lead, which is a lot heavier, has a bigger gravitational value. So obviously, it's not due to electromagnetism. Not only that, but you mentioned that G or Newton's equation doesn't take time into account. If I'm applying a constant pressure, you don't need time to be a variable. You need time when you're seeing change over a time. So when you experience change. If gravity does not change because it's a constant, you can leave time out of it. But if you want time out of it, you're not going to understand what I'm saying here. So I encourage you to go back and watch this again. But mv to the second over r can equal big G m1 m2 over r to the second, which is Newton's equation. Now, canceling out the m's on both sides and canceling out the r on one side and one of the r's on the other side in the Newton's equation, you get v to the second equals gm over r. What is v to the second? V to the second equals velocity. What is velocity? Distance over time. So you can have distance over time equal an equation that has the universal gravitational constant in there. So if you are so upset that there's no variable for time in there, you now have a clear example that shows how time can be equivalent to that and give you an answer that not only works, but is predictable. And that's why it works, because it is predictable. So As far as gravity goes, gravity is one of the most well-known pieces of science and the one that's the most corroborated for a while, considering that they have been testing this value, big G, for a while now with ever more increasing apparatuses that give us an increasing level of accuracy, or better apparatuses for better accuracy. So I'm not sure what the big holdup here is, but yeah, G is known. Gravity is a thing, and it's not electromagnetism.
David.
Yes. All right. All right. You about the senses, right? You said that they're not perfect. Now I agree with you in a sense, but we use tools and other things to improve our senses. But from what we got, they're pretty good. I mean, you trust your senses to keep you alive every day. You trust your senses to help you do a lot of different things. And when you're mentioning like the was it the merry-go-round, right? That you wouldn't feel it, but we're now. We're talking about like what supposedly the Earth is supposed to be this huge thing, right? That circumference is what 24,000 miles, and we're on that means we're on the outer edge of this merry-go-round, like your example is, and that we'll definitely feel that because we're being on the outside of it. It's gonna perceive to us to be a lot faster than being the closer because the closer you get in, you won't really feel that. Too much, like kind of like what you were saying, but that's not the same as what we should feel being on this huge Earth that you mentioned that is being on 24,000 miles, so I do believe our senses do work well, and I mean, of course they're not perfect, like a perfect in a sense that from what we need them for, it's good for what we need them for, right? But to improve our senses is what we use the tools for, but I'm pretty sure we could feel if the Earth was spinning, being that we're on this outside of this merry-go-round, right? And then let's see the next thing that you had mentioned. What was that?
You sound much better, by the way.
Okay. As far as the gravity thing, you said I'm not sure exact words, but that it works well for everything, but it actually doesn't, right? Because that's why they had to include all these outside things that we've never even witnessed, that we never even observed, like for instance dark matter, right? If they didn't put dark matter in place, then the planets will be going faster than what they perceive to be going, right? So that it does not work well. I mean, whoever does experiments on gravity, they always have to try to make excuses for why this does that or why this does that, and that's what they include because they have to keep gravity. They want to keep gravity, and that's just the frame of mind that they have. Anytime a scientist talks about gravity, they say that while the world is round, or the world is a ball, a sphere. So it must be something. So they try to figure out something, and they try to implement things that they never observed. Like for instance, that whole thing that I know specifically about is the dark matter that we've never seen, felt, touched, or anything about dark matter. Right? It's something that they conjured up in their mind because they needed something to put in place there. So gravity does not work well to what we witness, to what we do. So they just always have to put these things in, but that's gravity does not work well at all, and I still the formula that you put out there, I mean, I'm not exactly sure like you're right. I don't really know too much about it, but I'll look into it. But that's what I have.
Okay. Dark matter has absolutely nothing to do with planetary orbits. Newtonian physics actually explains orbits perfectly. That's why we have things such as Kepler's third law. The square of the orbital period of an object is proportional to the cube of the semi-major axis. We have been able to use that fact to do some pretty amazing things, like launching satellites to other planets and so on, figuring out the distance to the sun, which is another thing. So yes, these constants, which can be derived from Newtonian equations, do work well. In fact, they're used to this day to figure out a lot of stuff. In fact, did you know that you can use these constants to predict what the orbital speed of the International Space Station should be at a certain altitude. And then from there, you can actually determine whether or not the International Space Station is traveling at that speed. You will find that your answers actually will agree with each other. So once again, gravity made a prediction, and that prediction turned out to actually be the case when it was actually investigated. So yes, gravity actually does work well. Dark matter is called dark because it's something that we don't know. Dark matter is more on a galactic scale, not a planetary scale, where that's still an ongoing level of research. But just because scientists and physicists and astronomers are still trying to figure out dark matter, that doesn't mean that the physics on the small scale, i.e. the planetary scale, aren't well known enough to the point where we can accurately make predictions way off into the future. Like, for example, figuring out when the next eclipse is going to happen of Venus, even though we're going to be dead before it can be seen. It was predicted at a time when other people wouldn't be alive to see it, and guess what? It turned out to actually be the case because those equations actually comport to reality. So yes, the equations do work. They have always worked. They will continue to work. And if you want to verify it for yourself, you have the tools and equipment necessary right now because you live in the age of the internet where information is plentiful, and people like me are more than willing to help you out in understanding it. And the final thing is the census thing. No, I'm sorry. Your senses are not going to be sensitive enough to detect a rotation of once in a 24-hour period. It doesn't matter if you're in the center of the clock or on the outside of the clock. If that clock spins once in a 24-hour period, that speed is crawling. It is slow. Such a slow speed is not going to register at all with your senses. Yes, I use my senses every day to keep myself alive. But I'll tell you one thing. When I'm looking both ways across the street to make sure I don't die, the only thing I need to do is tell if that car is going fast enough and if I can make it across. And they're traveling a lot faster than one revolution in a 24-hour period. Of course, if I were to just look at a car whose wheels were turning in one revolution in a 24-hour period, I would have said that it's not moving at all. At least that's what I would be looking at. So no, senses are not perfect. Your senses are not perfect, and appealing to them is a flaw in your methodology.
David.
Yeah, I mean, you're trusting your senses to see, because well, according to your model and the globe model, you're saying that you're using your senses to perceive the sun to be moving. What is it? I forgot what is it? 15. What is I forgot what it is. But like whatever you say that Bob proved, right? What that measurement right there is what you're saying. You're using your senses right there to see it move, right? And so if you're using the sense to see the sun, why can't it be used to see the earth moving? I mean, you're just going kind of back. You're just going backwards. And then if dark matter wasn't used, then what would happen if dark matter wasn't there at all? I mean, are you saying that the celestial bodies that we see, like are within our solar system or within our galaxy, that nothing changes? Of course it changes. They're different. They They move at different speeds. If you don't have it there, it would go faster. The movements of the celestial bodies, they will go faster than what they are. So if you remove dark matter, they need dark matter. And they need dark matter to be included, and whenever they're trying to figure out the movements of the planets. I mean, it's needed, but we've never seen it, or like I said, we never felt it, seen it. We don't know what it is. I mean, as far as I'm concerned, it's nothing. They just put it in there because they needed it. It's like if you had I mean, a basic algebra formula, right? And you had to solve for x. You just include some other random variables. That's what they did to make it fit. They just got this random variable that made sense, and they made it fit into their formula. I mean, that's all it was. What was the last point that you made? I think I got all of them right there. But yeah, that's what I think right there.
All right. Well, anyway, when you say that dark matter is needed, I'm telling you right now, no, it is not, and not on a planetary scale. And I like how you either forgot or completely ignored how I explained how you could verify this for yourself. you can use Newtonian equations to figure out how fast the International Space Station should be traveling at a certain altitude. Then you can go outside and have it plotted. You can use tools such as a telescope or astrometry and figure this out for yourself. And guess what is not included in those equations? Anything to do with dark matter. All these variables that you can put into these equations are known variables. In fact, you can actually use this in a different way. You can use this to predict where Mars is going to be at a given time. You can use this to predict when the next solar eclipse is going to happen or the next lunar eclipse. I'll tell you one thing flat earthers have never done, and that is accurately predict a celestial event. Guess who has? The people who understand the heliocentric model and the round earth model, since they're one and the same in this context. So no, dark matter only applies to the really big scale. I'm talking galactic scale. They're trying to figure out why the outside of a galaxy spins at a certain percent of the inner galaxy, and there's some discrepancy there. That is all well and good. There is a discrepancy there, and I understand that there are some things about the cosmos that we just don't know. But when it comes to our local neighborhood of planets, when it comes to our planet, when it comes to our sun, when it comes to our gravitational field, if you will, we have a pretty good idea of what's going on. So good, in fact, that we're able to make predictions decades and even centuries into the future and have those predictions play out. Flat earthers have never done this because flat earthers don't have a model that comports to reality. Jeranism was a really good example of just that. So these equations, these constants that, by the way, you say are wrong because they don't take time into account, accurately provide us with a model in which reality comports to. So reality is agreeing with us, the predictions agree with us, so what seems to be the problem?
You mentioned that how they are in our the closer with us the planets are that are nearest in our solar system, that, but I mean there's a documentary on the Discovery Channel that specifically says that the dark matter is needed, also, or else the rotations of the planets will go faster. And I mean I could pull that up or anything if you want to see, but I mean that's according to them. That's an outside source. That's not me against you. It has nothing to do with this conversation. And I'm according to them, that's what they say. And so that's what I'm going by. That's what I'm referencing. But as far as the ISS, I did forget about it. I'm pretty sure that you believe that there's people that are living in this craft or whatever. I don't believe that. I know we see it there, but I don't believe that it's people living inside of that thing. I mean, there's more evidence to suggest that they're faking it, and I really don't want to get into a conspiratorial side of it, but I mean there is more evidence to show that they're faking it than actually people living on it. I mean there's it's just a lot of stuff like that, but and I mean as far as that in the sky, I mean I'm pretty sure you're right that it would conform to the formulas, but I just don't think that there's people living in there. I just think that's an impossible thing to do. Have people the way it's going at the speeds it's going, and I just don't. It just doesn't conform. I just don't think it's reality. But I mean, you probably think different, of course. But yeah, that's what I think.
Whether or not people are living on the International Space Station is irrelevant. We're using the International Space Station as a placeholder for Newtonian equations, placeholder in which we can use to provide measurements to see if the equations comport to reality. That's the point. Whether or not people are living on the space station, that's irrelevant to this. The point is that we can use the International Space Station to make measurements. And with those measurements, we can confirm the equations. That's the point. So if you want to say that people aren't living on the space station, fine. I'll agree with you just for the sake of argument. That does absolutely nothing to the topic of this current of what we're currently talking about, which is, do these equations, which has gravity in them, comport to reality? Can these equations that has gravity in them be used to make accurate predictions? And they can. So not only have they been used to make predictions, but they've been used to make predictions decades and centuries into the future. We know when the next opposition is going to be of every single planet in our solar system, years and years and years ahead. So obviously we have a pretty good lockdown on how our, at least our own solar system operates. So I'm sorry, whichever Discovery Channel documentary you were looking at, it had to be something really close to Ancient Aliens right now, because that is a load of crap that can easily be debunked by downloading something like, oh, I don't know, a Newtonian calendar or a celestial calendar, which can accurately predict these events in the future.
It wasn't nothing like Ancient Aliens. That was pretty funny though. But it was somebody. It was Morgan Freeman was the narrator. I'm not sure which one it was. But I could pull that up for you. But okay, so you're saying about the International Space Station, it that predicted, or it goes along to with the formulas. But what about the other movements in the sky? They don't. There's a lot of stuff in the sky that we see that they go at different speeds. I mean, they just found one out there that conforms to what their formulas say. I mean, there's a lot of things that go out there. That some go fast, some go slow, some go what do you call it? They're going in one line, and then they just automatically go in complete reverse. I mean, there's a lot of things out there. I mean that doesn't go by the formulas. That doesn't conform to gravity, and they're out there also. I mean, of course, we don't know. We don't know like how far they are, but I mean, I don't think there's anything above like we're like to above the ISS, or actually in what is it? Everything's in low Earth orbit. Nothing's above that. That's what I believe. But yeah, I mean the other celestial bodies, they don't follow the formulas or anything that's out there.
I'm going to need some citation on that, because I got a bunch of citations to show that they actually do follow it. And by the way, going backwards, that motion is called retrograde motion. Retrograde motion does not conflict with Newtonian equations. I don't know who told you that, but they're obviously feeding you some demonstrably false information. Newtonian equations.
I'm not talking about that.
Newtonian equations do not care about the direction of an object. And also, you said that some objects go fast, some objects go slow. Yes, but they all go fast or slow according to these equations. For example, you can use Newtonian equations to figure out Kepler's third law. And in Kepler's third law, it states that there will be varying speeds of celestial bodies. The square of the orbital period of an object is proportional to the cube of the semi-major axis. Orbital period as in the amount of time it takes. So obviously they've known this. You're not telling me anything that these brilliant people haven't already figured out. Yes, some go fast, some go slow, but they all comport perfectly to Newtonian equations, which again has gravity in it. This conversation is such a great boost for gravity at this point.
No, I think you're wrong, because now I don't know what celestial bodies you're talking about, but I don't know. Have you ever got a night vision camera and look up in the sky and you see all the movements in there? There's a lot of stuff that are going a lot different, and they're not based on any formula. They're not going towards or conforming with the formula. I don't know if we're talking about the same thing, because what I'm talking about is stuff that we don't see. Just like with our bare eyes or with a telescope or anything like that. You see these with the night vision goggles. When you put them on, there's a lot of stuff out there that's moving that we can't even detect them, and that's what I'm comparing to the ISS. Those celestial bodies out there that's what I'm talking about.
The telescopes that we use, by the way, you said that we can't detect them, but you mentioned night vision where you can detect them, so obviously they are detectable. Of every single object that has been observed by myself and another YouTuber by name of Astronomy Live, we have been able to figure out its orbit. And those orbits, when we look at Newtonian equations, those orbits conform perfectly to those equations. So sure, you can actually go into, like, for example, the precession of Mercury, and that one doesn't quite fit with Newtonian equations, but Einstein's general theory of relativity has solved that out quite easily. But for the sake of making general predictions, Newtonian equations actually work out perfectly. And all of the celestial bodies that is in orbit around Earth or around the sun, we have been using Newtonian equations predominantly, and those orbits match. So of all of the objects that we have observed, and with the amount of objects that we have been tracked, one of which, by the way, was discovered by Astronomy Live, he was actually able to figure out its orbit, map its orbit, and it's now in catalog as him as the discoverer. So obviously these equations are working. Obviously these equations are used to make predictions. So what exactly do you have, if anything at all? Can you give me one instance, one actual instance where these equations did not comport to reality within Earth, within our solar system, stuff like that?
I don't think we're talking about the same thing here, because the objects that I'm talking about, they like I said, they can't be detected. What I mean when I said that was that looking through a telescope or anything, but you only could see these objects with the night vision goggles. I mean, that's the only way you could see them. You can't see them with anything else. I don't know if you ever seen them or not, or what, you exactly know what I'm talking about. But you could look them up on. I know YouTube has a lot of videos of people that have night vision goggles and they're looking at them, but these objects are not even named. They're just observations that people have all around the world of these objects that are moving in the sky. I mean, nobody knows what they are. I mean, at first they thought they were satellites, but they weren't going in the same path as satellites would go. And but I don't think we're talking about the same thing here.
Well, until you have one of these documented in a way that can actually be verified, I'm not even going to bother commenting on it. Let me go ahead and ask you this question. You say nothing can get past low Earth orbit or whatever. What evidence do you have for that claim?
Being that let's see, as far as I mean, the records show that as far there's like 500, a little over 500 astronauts have been into space, but that's all considered low Earth orbit, and only I believe it's 18 or something. I don't remember the exact number that have supposedly went past that. I mean that's first off, the odds of that happening is it doesn't work out, right? Because 18 people out of billions of people on this earth to go, if we had that technology to go past there, then that we should have more people that are going in there, right? That's just numbers wise. But anything else, I mean, there's I mean, I don't believe we went to the moon. Probably you do, but I don't. First off, if they supposedly say there's the Van Allen radiation belts, right? Now, if you believe that they're dangerous to people or if they hurt people, then nobody that supposedly went to the moon or supposedly went into space, the deep space, nobody ended up coming back with cancer or anything like that. You know what I mean? And I'm pretty sure from what I understand, radiation does harm people, right? I mean, you have to put on that lead vest whenever you go see a dentist. And the radiation in these Van Allen radiation belts are supposed to be a lot more intense than the radiation that we produce off of X-ray. So and all these astronauts and everything, none of them came back with any radiation sickness, or none of them ever got cancer or anything like that from the radiation that they supposedly went through. But I mean, I don't know if you think that's dangerous or not, but that's one piece of evidence right there.
Let's go ahead and say that all that is true. And by the way, it's not, and it can easily be debunked. But let's just say that all of that is true. Astronauts never went to the moon. NASA never launched anything into orbit. You know, whatever. Let's go ahead and take all of that on board, just for the sake of argument. How does any of that show that, like, let's say the moon isn't further away than the International Space Station? How does any of that show that the sun isn't 93 million miles away? I'm asking for evidence to show that everything is small and local, which is the predominant belief of the flat earthers, or am I, straw manning you right now?
I mean, it's pretty accurate. I mean, there's no proof that the sun is 93 million miles away. I mean, there's as far as the sun, of course, the sun is not. No, what is it? 300 and what is it, 327 or something like that, 1,000 miles away. That there's no evidence of that. Well, I mean, where's the evidence of that to show that it's these great distances? The stars. I mean, they're talking about light years away. I mean, we can't see nothing that's light years away. You yourself said that we can't trust our senses, but you want us to believe that we could see light years away. But I mean, there's no evidence to say that it's all these great distances.
The distance to the sun was determined back in the 1600s, sir. And by the way, they did not use their senses to determine that. They used optical equipment, telescopes, and measuring apparatuses that could make the measurements for them. We were able to do that using the opposition of Mars. Other people have used the transit of Venus. At this point, Dave, question: is there any chance that I can screen share something to everyone?
Well, as far as the transit of Venus,
hold on a second.
Hold
on a second, David. He asked me a question, and I know it's confusing because there's two Davids here. Screen share is a little bit tough with this, Reds. So if if you want to share it, then you can send it to me. I can pop it up.
Okay, yeah, I'll be sending you a bunch of images, but yes, I do want to show something. It'll just be going next. But keep in mind what was being said as I send David these images. What was being said is that there is no evidence to show that the distance to the sun is what we say it is, and I'm going to argue that that's blatantly false. There is more than one way you can figure out the distance to the sun. I'm going to do one not too long from now, which will be the opposition of Mars. But another way that can be done is by using the transit of Venus, which I know we won't be alive for, but this is a methodology for how it was done in the past. So David, they should be going to you right about now. So go ahead and show these slides as they're popping up. All right. All right, David, go ahead and show slide number 1, please.
1 second, Red.
Thank you.
GE, any thoughts you have while we wait?
Well, I'm wondering a few things here. I'm wondering how strong David's math game is. I'm wondering so many things at this point. I mean, honestly, I face palmed a few times already, and I can't even think about what made me face palm. I know that the dark matter conversation kind of had me curious because David's talking about it on a planetary matter, like apparently dark matter is needed for orbits, when like Rhetoric mentioned that it's more about the galaxies, like the gravitational anomalies or whatever that we see between galaxies and stuff like that. Like that's where dark matter comes in, and that had me kind of curious. So I don't know. I'm also kind of curious as to what electric gravity is. Like, do you need double A's for this electric gravity? Is there some massive switchboard that turns the gravity on and off?
D-size batteries.
D?
Energizer.
Yep. GE D-size batteries, I would say.
Oh, nice. I see what you did there.
I'm straight. Yep. And
Dave,
so like I said, these I sent these in order, Dave, producer David. So yeah, when I just say next and go to the next one, that'll be just that one right there. So yeah. But I do want to say something to before these slides are shown to David Muniz. I hope I'm pronouncing that correctly. Because the curvature of the Earth is something that is known, I know many flat earthers are going to disagree with me when I say that the curvature of the Earth is known, that it has been measured, it has been documented, and it can be measured again and again and again ad nauseum. We know the curvature of the Earth, which means that if we know our position on the Earth, we can draw accurate baselines from 2 observation points. That's the first thing that I want to say. The second thing I want to say is that when doing these observations, either you're going to need a visual reference that you can build off of, or you're going to need optical equipment that is sensitive enough to make the observations. And computerized telescopes will actually track every data point for you on your computer, the computer that's running the telescope. So when David shows these slides, just keep both of those things in mind, and I'll show you how the distance of the sun was determined. And there is more than one way of doing it, yes, but this is the easiest way, at least I was told, to understand. The other one requires the opposition of Mars. Okay, so this is slide 1. So here's some basic trigonometry for you. You have a baseline, you have an angle, angle theta, which is right there at the top of the triangle. You can figure out the distance x. Baseline over tan theta equals x. That is basic trigonometry. No flat earther should deny that. And if they do, then they're full of shit. Next slide, please. Now, regardless of your baseline, you will have a line of sight between you, Venus, and the sun. This is, of course, assuming that Venus was transiting the sun during your observation, which it isn't going to do for over 100 years or close to 100 years or something like that. We'll be dead before it happens, but this is just one method in which it was done. So you have a baseline, you have 2 lines of sight, and from those 2 lines of sight, you can build an angle between you and Venus. And since angle A equals angle B, you knock out 2 birds with 1 stone using that method. Next slide, please. Using the values that you got, we got a value for theta of 1 over 60, so 1/60th of a single degree. Our baseline was 1.3 times 10 to the 4 kilometers. With that, we were able to figure out that we have enough values to actually build an equation off of it. So that would mean that the distance to Venus at the time of the transit was 4.5 times 10 to the 7 kilometers, which is a lot further than any flat earther would admit that such distances actually exist. They want to say that everything is within our little dome or whatever it is, and they say around 3,000 miles. That one observation shatters, just completely obliterates that conjecture. Next slide, please. Next, we have Kepler's we have this one, which is 1 AU equals the Earth's sun distance. And at the top corner, you see Kepler's third law. The square of the orbital period of an object is proportional to the cube of the semi-major axis. With this, you can actually build a ratio. So since we know that this means 0.8 AU equals the Earth-Venus distance. You know it because you can measure it, because we know the period of Venus as well. Since we know the orbital period, we can construct a ratio. If Earth equals 1, that means Venus would equal 0.3 of an AU. So D equals 4.5 times 10 to the 7 kilometers, which equals 0.3 AU. Next slide, please. Because of that, you're able to construct a ratio. If D equals 4.5 times 10 to the 7 kilometers, which also equals 0.3 AU, that means 1 AU divided by 0.3 gives us a ratio of 3.333 repeating. So if you take 4.5 times 10 to the 7 kilometers, times that by the 3.333 repeating, you get an answer that's roughly 15 times 10 to the 7 kilometers, or 150 million kilometers, which is also around 93 million miles. By using the transit of Venus, you would get the same value if you were to work this off of the opposition of Mars and so on. But yes, the distance to the sun is known. It has been measured. You can measure it yourself, and we're more than happy to help you out with that. Thank you very much, David. I appreciate it.
Now I understand your geometry equations and everything. I understand, but how are you determining the distance from Earth to Venus?
Parallax.
I don't understand how you parallax. But I mean, how can you use parallax? I mean, parallax is like how do you do parallax? Tell me, how do you do parallax?
Simple, because the sun has a known angular size of around 0.53 degrees as seen from Earth. That can be measured directly using astrometry. If we have 2 observers, they're going to see Venus transit a different part of the sun. If we use those 2 tracks, those transit tracks, we know that they take up a portion of that 0.53 degrees. Now, how do we figure out the portion? you can do a bit of pixel counting on the image. So you count the number of pixels wide of the sun, and then you count the number of pixels between your two tracks. From there, you can construct a ratio. For example, I did the exact same thing when measuring the altitude of the International Space Station. I counted 962 pixels wide and around 400 something pixels wide, something like that. Anyway, it came out to a ratio around 4.2 something, whatever. Anyway, so if I did a 0.29 and I divide it by the ratio that we just found, that will give us the angle theta that we need. So that's how you do parallax measurements.
So you're telling me that you're measuring how big Venus is? What's your reference? You're referencing the sun, or what do you mean?
I'm not measuring how big Venus is. I'm measuring its position on the solar disk. So if it transits a different part of the sun for one observer and it transits a different part of the sun for the other observer, those two observations can be used to figure out a parallax value. That parallax value comports to the angle at which we need in order to use Kepler's third law to determine the distance to the sun.
So you're saying the movement is determining your angle? Is that what you're saying? The angle that you need?
Its position on the sun. Okay, so for example, let's say the span of my sun is 962 pixels tall. Let's say at the time of my observation, I took an image of the sun, and that sun was 962 pixels tall. As it transits, Venus transits the sun, it's going to leave a trail. If I take a picture and take another picture and take another picture, you're going to get a trail of motion. The other observer that's a lot further away from me is going to see their own trail on a different part of the sun. So you have two trails to work with. So you have 962, and let's say the span between our two tracks is 224. That would give us a ratio of 4.29 to 1. So if we take 0.53 degrees and we divide it by the value we just found, 4.29, that gives us a value of 0.1212 degrees, which would be the value I got when measuring the distance to the International Space Station. The value that we would get for Venus would be different because it's a lot further away, but that is the methodology.
I get what you're saying, and I see something wrong there, because you're talking about the pixels of the sun, but we don't even know how I mean, that's what you're trying to get to. We don't even know how big the sun is. I mean
no,
that's what you're using pixels.
We do know how big the sun is in angular size. Its angular size can be measured directly, and has been measured directly. You can do that through astrometry, or you can do that with a pinhole cutout and figure it out that way. But no matter your method, the angular size of the sun can be measured directly. And in fact, I want to go ahead and have David show something else to you. David, I'm sending you a video link right now. Please play it and pause it at 8 minutes and 42 seconds. All right, 8 minutes and 42 seconds. This is going to give you an example of how I was able to use parallax to make a measurement. Once David gets it up on the screen, you'll see exactly what I'm referring to here. But just to kind of put this forward before David gets up there, because I know he needs some time, we're talking about the parallax tracks. As Venus transits the sun, it's going to leave a trail. We can use that trail for me, and we can use the trail of another individual that's a lot further away from me, and figuring out our parallax between those 2 points. So that would be how parallax is measured, whether you're using it to figure out the International Space Station, Venus, or even Mercury. It just depends if you have the equipment needed to do the measurements. There we go. Okay, so as you can see on the screen, I was in one location. My tracks are on the left. Astronomy Live was at a different location about 1 kilometer away from me. His tracks are on the right. Now, Dave, please go ahead and play it. Make sure the audio is muted, and I'll tell you when to pause. All right, so now what you're going to see here is from this image, I can actually figure out parallax measurements. Pause it right here. So here you see that I measure how many pixels tall the moon is, 962. And I measure how many pixels wide the two tracks are, which are 224. Dave, go ahead and play it. Now this is using Astronomy Live's image, but we counted his pixels using Photoshop. You can count pixels using Paint, I think. But anyway, no matter how you count pixels, you can. You take 962 divided by 224, you get a ratio of 4.29 to 1. If we take 0.53 degrees, which is the angular size of the moon, and divide by 4.29, you will actually get a value of 0.1212 degrees. And since angle A equals angle B, that means B is also equal to 0.1212 degrees. Dave, thank you very much. You can take down the video. That's how you do parallax measurements. That's how you would be able to get angles. Whether it's the International Space Station or Venus, the methodology is exactly the same.
Okay. Can I tell you where I believe it's wrong and because look at. All right. So say you're looking at the moon, right? We see the moon all the time. Everybody sees it. Have you ever seen at times when the moon is like double the size? I mean, the moon size it varies in the sky all the time, and so I mean that throws your measurements all off. What if you're using the moon when it was at a different size? It's different sizes. I mean those measurements will be all off, and especially with the sun. I mean there is an apparent sun, right? I mean what are you putting your pixels at, on the apparent sun or the real sun, or what do you?
Correction, the angular size of the moon does not change. In fact, here's a good way that you can prove that to yourself. Have the moon at the horizon where it appears biggest. Hold out your thumb at arm's length right next. You will just about be able to cover the moon as it is in the sky. You'll be able to cover it fairly easily. Wait till that moon is at your zenith. Wait till it's way up in the sky and do that again. You will be able to cover it by the same amount. When people say that the moon looks big in the sky, that is an optical illusion. That is not reality. When you want to, or it's not reality to say that's actually double the size, I should say. But if you hold your thumb up and you compare the size of your thumb next to the moon and then do that again when it's way up into the sky, you will actually see that the size of the moon did not change at all. This is just another example of your senses failing you, because your senses told you that the moon was double the size. But when you actually measured it, it turned out to actually be the same size or really close to the same size. So not only is that an example of your senses fooling you, an indication that you shouldn't always trust them, kind of leads you down the rabbit hole of what else you can't trust your senses on, but it shows that my observations are actually valid. Not only that, but I was able to measure the angular size of the moon directly that very night using astrometry.
Yeah, but I don't think you understand it, because if you're looking at the sun and I mean, if you're measuring it, if you're using the sun and measuring it with your measurements right there, I mean, how do you know that you're not measuring it at the time when it's you're observing it bigger than what it is? I mean, because there's a lot of distortion in between in the atmosphere that's why it causes the sun to look bigger than what it is. I mean, go ahead.
The angular size of the sun can easily be determined using a solar filter. And not only that, but when the sun is in the sky, we have figured out what the angular size of the sun is already. And so any variation that would have been seen throughout the day would have actually been taken into account over observing the angular size of the sun through a number of days. And when observing the angular size of the sun through a number of days, we see that the change is so minuscule that it might as well not even be there. You're talking about a change, like, for example, from morning to noon of 0.0002272 degrees, which is basically no change whatsoever. So for me to say that the angular size of the sun is 0.53 degrees, the worst you can say is that I'm wrong, by 0.0003%, which is basically not much, which is basically telling me that I'm absolutely correct. So using those values is not wrong, it's not fallacious, and you can get an answer that comports to reality. Keep in mind, we're not using this to get a definitive answer. We're not using it to get an absolute answer down to the last centimeter. We're looking to get an answer that is good enough so that we can get a general idea. And using my method, you will get an answer that is accurate to within 1.4% of the current accepted value for the distance to the sun. What does this blow out of the water possibility? That the sun is small and local, that's 3,000 miles away, and that's held up by magic, aka the flat earthers have absolutely nothing to go on, along with their inability to make any sort of predictions whatsoever.
I mean, the predictions are there. I mean, we know where the sun's going to be all the time, and that's the flat Earth model does that. I mean, you could tell where it's going to be at, what location is going to be over. But I mean, you're saying that it's small, but you're talking about 93 million miles away, which is a great distance. I mean, the angle you're talking about is here local, but when you multiply that for 93 million miles, I mean, you're talking about a big distortion.
Nope, there's no distortion, because the only distortion that you're going to be seeing is limited to our own atmosphere, and our atmosphere goes up maybe around 100 kilometers. Let's say it goes around 100 kilometers. That means you have over 92 million miles of no atmosphere, i.e. no distortion between you and the source of light, which is the sun. So that means you only have to account for 100 kilometers of distortion, which, by the way, once you observe the sun over and over and over again, day after day after day, which people have been doing for, many, many decades, they see a consistent theme when it comes to the angular size of the sun. The angular size of the sun is known. Any variations has been accounted for and averaged out, and it still doesn't deviate from the original value found. It comes out to around 0.53 degrees all day, all year, all the time, no matter where you are on the planet. That can be verified. You can verify that for yourself. And if you think it was just a fluke of the atmospheric conditions of the day, do it again. Then do it again. Then do it again. And then when you think you're done, do it one more time just for good measure and compare your values. You will see that your values will continuously remain consistent if you do your observations on a day where you can actually see the sun to begin with.
Yeah, I understand what you're saying, but I still don't see how the measurements are accurate to show like the sizes. That I still don't understand that. I mean, the numbers that you show, I mean, I don't really understand how that could be accurate.
Because trigonometry is a thing, and just because you don't understand it, that doesn't mean that other people can't apply it and get accurate measurements off of it.
Wrong. I mean, I know what geometry is. I understand the formulas work, but I'm saying the numbers that you're using are wrong.
How are they wrong when I showed you a clear, demonstrable example of how I got them to begin with?
I mean, you're agreeing with me that there is distortion. I mean, how there's distortion in there. You agree with that, but you're just trying to say that it doesn't change often, but it does. It always changes. I mean, there's times when the distortion is like on certain days I can't even see the front of my car when I'm driving. I mean that it varies. There's a lot of distortion, and that's compounded when you're looking. The farther you go out, it's compounded when the farther you look out. Because I'm just talking about looking at the front of my car, but that over distances, it becomes a lot more.
The reason why you can't see your foot. I'm sorry. The reason why you can't see your foot is because there's a steering column in the way, sir. The same way that the reason why you can't see the bottom of buildings in the distance is because there's a giant hump of water in the way. When you're looking at the angular size of the sun and you're looking at the angular size of the moon and figuring out parallax measurements and such, the atmospheric distortion, whatever, is not so extreme that you can't use it to get a value. At the very least, get some ideas completely blown out of the water. Let's hypothetically say that I am accurate to within 10%. Let's make it 50%. Let's say that I am wrong by 50%. Let's say that I give you only a window of possibility that the sun is anywhere between 50 million and 93 million miles away. Let's say I can't even get really that accurate. There are certain things that I can eliminate, though. There are certain things that I know are impossible with the evidence that I have gathered. And the thing that is impossible is the idea that the sun is 32 miles wide and 3,000 miles up. It completely gets rid of that as any sort of possibility, because the trigonometry doesn't work for that. The observations that we do doesn't work for that. The measurements that we do doesn't work for that. In order for the flat Earth theory, let's call it a theory, to actually hold any water whatsoever, it would have to comport with at least something, but it doesn't comport with anything. But yet, when we do these observations, even with the limitations of the atmosphere, let's go ahead and say that they're actually limitations, we're able to get an answer that is accurate enough that it is literally to within 1.4% of the current accepted value. So obviously this atmospheric distortion when it comes to the angular size of the sun is not in any way, shape, or form being besmirched by the atmosphere. Our measurements of the angular size of the sun are consistent with the predictive capabilities of the heliocentric model. They're consistent with the current accepted value that has been found by not only optical equipment here on Earth, but also optical equipment in space. Like it or not, we actually have stuff up there that can do the measurements. SOHO, for example, does it. So all in all these different methods all converge on the same answer when it comes to the angular size of the sun, the actual size of the sun, the distance to the sun, and so on. So at this point, what else is there left to talk about?
But you're saying that you're saying the ratios work out with all the numbers and everything. But even if we were to say that your measurements are all correct, and they conform to what you select. But if you were to do it another way, right? Say you have the sun at 93 million miles away, and if you were to like just hypothetically speaking, if you were to bring it closer, like halfway, and you cut it down to what it would be from 93. You're looking at 42 and a half or something, 42 and a half thousand miles or million miles away, and so then it would be bigger, right? Like be like double the size, right? Bringing it closer. If you were to cut the miles in half, it would grow to half the size of what you see, right? And if you were to keep on doing that to bring it, it wouldn't fit. That wouldn't fit into the numbers of being 93 million miles away. It would be too big. It'll be like over us. If you were to bring it in, like the distances as far as the ratios are concerned, it wouldn't work out like that. I mean, you're just putting it work out to what it works out best for you.
We don't use the angular size of the sun to measure the distance to the sun. What I did was I used the parallax measurements of Venus, which again is independent from the angular size of the sun. I then utilized Kepler's third law to figure out the distance to the sun. So its angular size is irrelevant. What you're talking about is scaling invariance. And scaling invariance is something that Jeranism likes to constantly harp on about, even though we do not use the angular size of the sun to measure the distance to the sun. That is a straw man of what we've been saying the entire time. So if just hypothetically, if the sun was twice as big, even if it was 3 times bigger than what it is right now, that wouldn't matter because the laws would still apply, parallax would still be a thing, trigonometry would still be a thing, and we would still come to the correct value. And if you construct a universe and you give me those parameters, I will be able to figure out the distance to the sun every single time without fail. I challenge you, build me a solar system with just random values plugged in, and I will be able to figure it out. Because trigonometry doesn't arbitrarily stop working the very moment you make the sun bigger.
Right. I mean, I agree that's going to be right. And of course, I mean, all you're doing is just either multiplying the numbers. I mean, it's all going to equal out in the end of the day. But the numbers that I'm talking about, that's what I think is wrong. The numbers that you're using are wrong. But of course, you could, if you were to make the solar system smaller, and you just do it all proportional, it's going to come out the same thing. It's because everything's proportional. But I'm saying those numbers that you're using to the numbers that you're using, those are what's wrong. And that's what I'm saying. I'm not saying the proportion wise. Of course, that'll equal all the same.
Well, how are they wrong?
That's what I'm trying to tell you, that how you're trying to measure it. How can we confirm that? How can we confirm that the angular distance you're talking about is accurate? I mean, how do we know that you're not mistaken? I mean, we can't get a ruler and go measure it. Excuse me?
Do it yourself.
But what I'm saying is we can't get a ruler to measure to see if it's accurate or not.
He doesn't believe in the method, Reds. He doesn't believe in the method, not just you. He doesn't believe in the method that's being done.
He doesn't think math is real.
Basically, he doesn't believe that trigonometry can be used to figure out the distance to objects.
I told you trigonometry is real, and it's a thing that I use. I've used it plenty of times. But what I'm saying is that the numbers that you're plugging into these formulas, those numbers are not right. I don't think they're right at all.
Then go out, do the observations, and verify it.
If I can,
go ahead, GZ.
Yeah.
Well, I was just gonna say, if I can, I mean, I feel like Reds has done more than enough to defend the globe model, if you will, the normal model. I'm kind of curious what David thinks. Like, how do you think that the sun is 3,000 miles away and 30 miles across? Do you have some other kind of idea?
I don't claim to know exactly how far it is. I don't claim at all to know exactly how far it is. I mean, the distance. I know it's closer than 93 million miles away, and I don't believe it's that far. Like the stars are not that far.
Well, okay. If I can stop, I'm very interested in what you have to say, but I do have to stop real quick because you say that you know for a fact that it's not 93 million miles away, but you're not telling us how you know this. How do you know that it's actually closer than that?
I mean, you're not gonna like my answer, but it was because I don't think we could see that far. I don't think we could see 93 million miles away. I mean, we wouldn't be able to see that, and like as far as the stars and light years away, I don't think we could see light years away. I mean, I don't have Superman eyes. I only have 20 vision.
Okay. How do you know that we can't see that far away? Like, what physical property of reality prevents us from seeing light that's 55 million light years away, or how many light seconds is it away from the sun? I think it's like 8 light seconds from the sun.
Eight light minutes.
Light minutes. Sorry, not seconds. Sorry, that's way too fast. But light minutes. What prevents us from seeing that?
Well, I mean, there's a few things first off, of course, it's gonna go to the size of it, but if you were to kind of bring it down to Earth and look at it like a light bulb from a distance, I mean, from a distance, we end up not seeing it after so far. I mean, the light doesn't just keep on going on forever. It stops somewhere. It doesn't just keep on going, and so I mean, 93 million miles away. That's way too far for. Yeah.
Well, I mean, the light dims out because of the spread of the light coming from the light source and how powerful the light source is. Considering the fact that our sun is a very powerful light source, I mean, if it's bright enough, don't you think we can see it from pretty far away? Because, I mean, if you think about it, if you use your light bulb thing here, then we really shouldn't be able to see, like, lighthouses from very far away. But yet, those are pretty big navigational tools that ships, at least in the past, use. I'm sure they still use them now to know where coastlines are and stuff like that. So, I mean, how do you explain that? I mean, the whole principle is the brighter you make the light, the farther away you can see it. Also, the elevation or how high the light source is off the ground, that makes a big difference too. But we're just talking about how luminescent the light is.
I mean,
Feedback is
you're
killer.
correct in everything. You're correct in everything you say, everything that you say is right. But we're talking about 93 million miles away. You can't even picture that in your mind how far that is. You know, that's
I
that's
don't
pretty
have a problem
far.
with it.
No matter how bright it is, we can't see it. We won't be able to see that far.
Okay,
And then,
but David, so I'm really sorry for interrupting you, but you have to
go ahead.
understand that you're saying that you know that we can't see it from 93 million miles away, that you know light can't go that far, but you're not actually providing us with any kind of information of what restricts light from going that far. Even in the face of me telling you, well, we have one light source that's 1 wattage, let's say, and then you have another light source that's much, much brighter, much, much more powerful, and you can see it from farther away, or you can see it over long distances. So I'm asking you, what physical property of reality stops light from propagating throughout the universe, indefinitely, if you will? What prevents that from happening?
Evil.
I'm not sure exactly what you're trying to say. Like what's holding it back? I don't believe anything's holding it back because I don't think it's that far. I think it's a lot closer than what it's said to be. Go ahead.
Well, no, I understand. I understand that that's what you think. I'm asking you to put yourself in my shoes and try to understand this, because you're telling me that I can't see something from 93 million miles away. But yet you're not telling me what limits light, given if it's powerful enough, then I don't see a reason why we shouldn't be able to see a light from that far away. Yeah.
Gallus, I think I can help. Let me try. David, I'm going to ask you a question. Headlights on a road. Could you see headlights coming towards you 1 mile out? Yes or no?
Depending on that, there's no nothing like the atmospheric conditions. Depending on how the atmospheric conditions are, because I have not been able to see it that far away in certain days when there was a lot of distortion. But
I'm talking about just the light. Okay, so it's nighttime, dark road, a car's coming towards you 1 mile out. Would you be able to see the headlights?
Yeah, I believe so. I believe you should be able to see it.
Perfect. Okay. So I went ahead and did the angular size calculation for headlights at 5,280 feet, and the angular size is 0.011. So now let me go ahead and just put that into perspective for you. That would be that would mean that the sun is 48 times bigger in the sky than those headlights, which you can see, and 48 times, and while being a light source. So if the sun is the size asserted and at the distance asserted and is a light source, which it is, you should be able to see it quite easily when you take into account that you could see headlights from a mile away, and the angular size of those headlights would be 0.011 degrees, not 0.53 degrees. You're talking about the sun being 48 times bigger in your vision. So why shouldn't we be able to see the sun again?
I mean, even if you were able to see it, that doesn't prove that it's 93 million miles away. Even if the numbers add up right, I mean, they probably should. As a matter of fact, now I think about it, but that doesn't mean that it's 93 million miles away. I mean, that's not what we see. We don't see that 93 million miles away. That's not where it's perceived to be.
Well, okay. Listen. I get your angle on this. Okay, I really do. But if all of the numbers work out for our model, for the sun being 93 million miles away, if everything works out on that model, but on your model you have still a lot of unanswered questions, what should compel us to believe in your model when it explain basic things. Like, for instance, if the sun was 3,000 miles away, you would have to explain what exactly it's made out of, how much light it's exactly giving off, why doesn't it set our atmosphere on fire. You have a lot of unanswered questions.
I'm not trying to tell you. I'm not trying to make you believe what I believe, but what I'm trying to tell you is that okay, supposedly that we've known the Earth to be a globe, round or whatever, for 2,000 years, supposedly, right? That's what they say. Now, if we had 2,000 years of time to test everything out, I'm pretty sure we'll get everything right too, and make it work as accurate as you have the heliocentric model working. But then another thing, if we had the funds to do it, I mean, all this been funded by a lot of different people, right? I mean, we've only had a couple of years, and we've a lot in the last couple of years to explain a lot of things. Couldn't be before explained. Now we're able to do things, but give us that time, give us the funds. Of course, we'll be able to explain everything, just like the heliocentric model does.
David, I'm going to give you one thing that you will not be able to explain, even if you had unlimited funds.
Hold on a second, Red.
Hold
on a second. Hold on a second, David. Hold on a second, David. You have to mute when you're not speaking. I'm getting so much feedback from you. The audience is complaining. I'm getting a headache. Please, sir, mute when you're not speaking. Thank you.
All right. Thank you
My
for
God,
that also.
you're getting salty.
Okay, so here's the thing that you will not be able to explain even if you had an unlimited number of funds. For the flat Earth theory to make any sort of sense, the sun would actually have to be what the flat earthers claim, around 35 miles wide, 3,000 miles up or whatever, in order for it to somewhat make sense with its position in the sky. But if that were the case, the angular size of the sun should change throughout the day. We should see it rise at one angular size, grow to 3 times bigger midday, and then shrink again to the size it was when it initially rose. The fact that the sun does not do that and will never do that, regardless how much money you throw at the problem, shows that you guys are never going to have a model that comports with reality, period. So simply throwing money at the problem is not going to arbitrarily make the Earth not a globe. The Earth is going to always be a globe, regardless how much money flat earthers throw at the problem. And basically, if a flat earther was to throw so much money that he made his own rocket to blast himself into space, well, guess who wouldn't be a flat earther anymore?
Two things on that, like as far as anything that's in the sky, it doesn't determine if the ground is flat or not. I mean, whatever it is, it does they have no connection. They don't physically touch each other, so they don't. It doesn't mean whatever what's going on in the skies does not show the shape or does not prove anything in the shape of the Earth.
It does actually.
And then second thing is that you said that it doesn't sizes, and I've seen it change sizes, and that's with the filter on it. That has been caught where the sun does change, but it's different all the time because of the atmospheric conditions.
Well, yeah, but I mean, if you use a solar filter, I mean, it's not distorting the angular size of the sun. I mean, you understand what a solar filter is, right?
Yeah, I understand what it is.
Okay, what is a solar filter?
It's the filter they put on the cameras. They put it on and it removes all the rays, the light rays, and everything. Just shows the sun directly.
Well, yeah, I mean, I'm sure Red's Rhetoric can go a bit more in depth, but I think that you got the basic idea here. It'll show you the actual size of the sun without the the glaringness of it or anything.
Blindness.
And yeah. And so when you actually use a solar filter and you track the sun, which you can find, I'm sure all across YouTube, you will find that it doesn't actually change shape, that the angular size doesn't change throughout the day. Whereas you should see drastic changes on the flat Earth model, and that's what Reds is trying to get across to you here. It should be a drastic change. It's not just like minor changes. It's a drastic change.
It's a drastic change by a factor of 3. So yeah, and by the way, no flat earther video that I have ever seen that reports to have caught a changing angular size of the sun has it changing by that amount, and most of them don't even have a filter on their camera to begin with.
And they misconstrue the changing in apparent luminous whatever luminescence
Illuminati.
or whatever Illuminati's.
What they're measuring is glare. They're just measuring glare.
That's right.
That's all they're measuring. They're measuring
I've
glare.
Seen it, I've seen it where it has a solar filter on it, and I've seen it change. I don't know about what you're talking about as far as 3 times, but I have seen the changes in the size and with the filter on it.
Here's the thing. The fact that you said that what you observe above your head cannot tell you anything about what is under your feet shows that despite your claims, you actually don't know the geometry behind the problem that you have when it comes to flat Earth. You need to look at what I am saying in every aspect. And the only way that I think you're actually going to get it, and no insult to you, but to actually draw it out. Draw a flat Earth, draw a sun, have your scales accordingly, and look at the angle at which you are viewing it, and then determine its angular size at different points over the flat Earth. You will quickly see the contradiction that lies within the flat Earth model, and that contradiction is not going away, regardless how much money you throw at the problem.
But I think you're mistaken. Excuse me. I just think you're mistaken.
I was getting ready to say super chat time, but go ahead.
Oh, okay.
I was saying that whatever you see in the sky, I mean, the reason why I understand what you're saying as far as geometry and all that, but what I'm saying is that there's a lot of different variables that get like for the atmosphere, it gets in the way and it distorts what you're seeing. So sometimes it might be bigger, sometimes it might be smaller. There's different things that get in the way, and all those variables you have to include. That's why it doesn't determine the ground that you walk on, because everything changes in the sky. Everything's different. It's not every day is not the same thing. There's a lot of differences when you're looking at things in the sky.
Kyle?
Okay. Yeah. All right. Let me just pull up the super chats. Thank you both once again for coming in, and that very, very cordial debate. Very cordial. It's always good and funny for me to see that when people post in the chat. Reds is being so nice tonight.
That's because I have a migraine.
Yeah. Let's see. Okay. All right. Here we go. Let me find a starting place here. Okay. Steven Steen, Reds about to get whooped. Vandy, 004, Kyle for best hair, # where's my wrench. Comment in the chat and I'll, bribery is the best way to get one for sure. Princess, April Van Ryn, left super chat with no message. Thank you. Peaceful Dusk. No offense to Klingons, but David, are you a Klingon? That's fucked up. Rapid X. Peeps who still don't know the difference between a pedo and a homosexual person are simply ignorant. Pathetic way to treat a friend. I'm shocked. You and me both, but I'll take care of that tomorrow. Don't you worry. Kuyasa, but I clearly see the curvature on screen. Oh, wait. Never mind. Zigzag left a super chat with a message. Matt Rock says, how I think it's for you, David. David, how are you going to need numbers but reject the math?
That doesn't even make sense, man. I don't even understand what he's trying to say.
Okay, I was just making sure that was okay. Princess April Van Ryn again left a super chat with no message. If that's a mistake, please comment in the chat and I'll say whatever you need to say. Brian Shannon, never bob unless you're underwater. It's funny. Demonic Davros, ouch, my IQ just ran away from home and took my oven mitt, so now my face hurts. You can borrow GEs. He has one. Hold on, let me knight Andy real quick. You already okay.
Already did.
Thank you. Cajun Drifter says, check out Bob the Science Guy's latest video, proving gravity with an iPad. Yes, Bob the Science Guy is amazing. The Athens 619, Flurfs, trust your senses. Flurfs, trust your senses. Blind people, Earth's not real. Okay, I got it. Got it. My unfinished journey, gravity is not electricity. Shocking and heavy. Joshua England, Reds, I don't have a college degree, and I know that the Earth is round and good reasons why. Can you say it like you think I would?
Okay. The Earth isn't fucking flat. Get your head out of your ass and understand this very simple fact. All right? Science doesn't give a shit about your feelings. Evidence is the only thing that matters. And all the evidence points to the Earth being round. Fucking deal with it. Get your head out of your ass. Again, please, seriously, I will give you a dump truck of Vaseline to help. Please, please.
Joshua England. That sounded just like you, Joshua England. Just like you. Who's your atheist? If Earth is flat, then how do you explain how beautiful Kyle's hair is with its curve? Checkmate, flatties. That's actually going to make me blush. I didn't read that one ahead of time. Thank you very much for that. Dapper Dino says, I can't figure out if the alcohol makes listening to Flat Earthers more or less difficult. Probably more. Also, I'm thinking of debating Kent Hovind, but that might also be the booze. Please let that be the booze. Do not debate Kent Hovind. Do not debate. Jimmy Kalman sent a message without a super chat. He sent a super chat without a message. Thank you. My unfinished journey. Nuh-uh. Demonic Davros. Holy word salad Batman. This is the joke, not the Joker. Wesley Smith, explain to me how the sun sets 365 days a year on a flat Earth. That doesn't contradict flat earthers. His reasons, boats disappear from the bottom up, or you only see the top portions from far away. I would like an answer. I'm assuming that's to you, David. So how do you explain the sun setting 365 days on a flat Earth to start out with?
That it's convergence, because you're it's an illusion that you're seeing it set. It's not setting. It's what you see, the convergence of the sky and the ground coming together. It looks like it's going over, or it's setting, but it's not. It's what you're seeing.
Kyle,
It's the what do you say, the horizons. It's an optical illusion. It's not because of the ground is curving.
No, David. Come on now.
May I, Kyle?
Yes.
Convergence is part of the law of perspective. The law of perspective is alpha equals 2 times the arctan of g over 2r. That equation states that as an object gets further away from you, it's going to shrink in totality in your vision. If there is still angular size to the object, which is discernible, you should be able to see it in full. The law of perspective does not state that objects, as they start moving away from you, are going to arbitrarily start disappearing bottom up and then eventually out of sight. The only way that happens is if something external to law of perspective is at play, which would be the curvature of the Earth.
No, that's wrong. And plus, you got a lensing effect that's not included in your formula right there. So you're missing that, and we know that the atmosphere is making a it's like it could be acted like a lens.
Go ahead, Kyle.
Okay. My unfinished journey. I want to hear more about these tan thetans. Jimmy Callanan says, your continuous content is constantly awesome. Fuck you, Emperor Atheist. Thank you very much for that. And yes, fuck you, Emperor Atheist. Tubian 323 says, well, hell, right in the Fuhrer's face. I hope I said that right. Who's your atheist? Maybe flat earthers would understand vast differences better if they had a bird's wide conversion chart. Elador says Dave doesn't understand what angular size is. Need to hold his hand and explain that part first, and then push him on the details of the related calculations. AC Castillo left a super chat with no message. Demon's Den, Flatomatics, 2 + 2 = 3 miles. End Flatomatics. Alan Beaupre, David, what would ever change your mind that the Earth wasn't in fact flat?
Say what would change my mind?
Yeah. What would it take to change your mind?
I mean, to have an actual like real video or a real picture of the Earth being round.
You have those.
That they're not real. I mean, they're composites. Sometimes
Okay,
they're drawings.
Sure, they are. There are composite pictures of the Earth, but let's say that I took 12 pictures of you, right, from different angles, and then I pieced them all together to make a composite of you. Does that mean that those pictures that I took to composite together weren't real? They weren't really you?
Yeah, I mean it's a real picture. I'm not saying it's not, but what I'm saying is that the composite, it doesn't show a complete sphere. You know, like I mean they're putting it together to make it look like that, but that's not the way it is. Everything's just flat. I mean that's how the pictures are taken.
So you think they took a flat? Okay, go ahead.
Let me try this. The Himawari satellite takes a picture of the entire Earth from geostationary orbit, and that image is 11,000 by 11,000 in resolution, and you get a picture every 10 minutes from that satellite. Not only do you get images from those satellites, but you also get images from those satellites that comport with the local weather. And it's used to make weather predictions. So yes, you are getting images from space. No, they are not fake. Yes, we have determined this to be the case. And unless you're suggesting that JAXA has, a lot more computing power to CGI crap at a resolution far higher that even Pixar could ever dream for, then you're special pleading at that point.
Well, why would they even admit? Why would they even admit that it was a composite, though? If they had the power to create a picture of the Earth, why didn't they just stick the picture of the Earth out there and say, "Here's the planet. We took it all in one shot." We wouldn't know the difference.
Well, yeah. Not only that, but they do in one shot all the time. In fact, you not only have Himawari, but you also have the Epic camera. The simple fact is that flat earthers do not want to accept images of the Earth, even though they are completely legit, because that automatically spells doom for their conspiracy. So their only recourse is just to assert CGI, they're fake, they're not real, and whatever, even though they have no evidence to suggest that these images, which, by the way, comport with predictive capabilities, and not only that, but can be used to make predictions from themselves. Right. Let me explain it to you this way. I take an image of my car. That image is computer processed, and there is this big gaping bug that just splattered right in view of where my eyes would go where my line of sight would be if I was looking at the road. I predict from that image that I will not be able to see the road unless I get my window cleaned. And when I actually do it, it turns out to actually be the case. And then someone goes around and says that image is fake, even though I use that image to make the determination to begin with. That is what we're talking about here. These images from space of Earth are used to make predictions of weather in areas on that side of the planet, and they work.
Sure. And the thing is, like, I know that there are pictures of the Earth in its entirety, but the reason that they don't accept those is because of the composite Earth, because that's the one thing that they get hemmed up on. But it goes back to that, like, David, how would you answer this? If we have the capabilities of creating a picture of the Earth in its entirety, why would they admit that it's a composite? Why would they openly say that this is a picture of the Earth that's pieced together? Why not just put it out there and say, here's the Earth. We took it all in one shot. I mean, nobody would know the difference.
Yeah. Well,
How would you answer that, David?
even if it would just be, they would find some other
Yeah.
excuse, in my opinion.
Well, how would you answer that, David?
Well, why are they being honest, or what do you mean?
Yeah. If they're lying about if they're lying about the shape of the Earth, why are they being upfront and honest about piecing together an image of the Earth? Why not just say, here's a picture of the Earth? They're already lying about the shape of it. Why not just throw the picture out there and say, there's the picture. We took it all in one shot.
But that's what they are doing. That according to what you're saying, like they're saying the Himawaris, where they are saying it's
No.
no.
I'm talking about the composite picture. Why would they say that we had to piece this image together? We couldn't get it all in one shot. Why did they admit that? Why not just put the picture of the Earth out there in its entirety?
I'm not sure why they would be honest this time. I mean, a lot. I don't understand why they do a lot of things. I mean, to me personally, I think a lot of the people in there that are in these space agencies are the ones at the top, especially are psychopaths for the things that they do. But I don't think like a psychopath, so I don't know.
They're psychopaths for making scientific discoveries and providing you with a life that you're taking advantage of.
No, for studying money and faking things.
All right, we gotta get to these. We gotta get to these super chat. Night Demon. So the flat Earth's flat like a CD, and the sun pops in and out of the hole. That's a lot of lube. Better start by buying Astroglide or gun oil. Robert Williams. If the angular size, gay people will get that. If the angular size changes 3 times, inverse square says brightness would change by 9 times. Yasan says, Kyle, may I have some Cinnamon Toast Crunch? Only if your homework is done. True Blue, everything gets smaller as it gets further away. Everything. Why is the flat Earth sun different? That's the second track off of, because you got the black hole sun is now flat hole sun. And then, G, what was the one that we came up with while I was over at your home location? Oh, the Earth is a treadmill. That's right.
Oh, yeah.
Earth is a treadmill. That's Pratt. Okay. Six more. Matthew Walker. This guy this guy hit his head on the dome. Says Fredo Sarabia says, why does a car's wheels disappear as it drives away? Princess April Van Rijn says, the question I asked was, how can anything orbit on a flat Earth model? I don't think it does. I think the space is fake and separated by the firmament. Jake 3D, does this guy know that angular size really means? Does this guy really know what angular size means? $20 if he can give a coherent, full explanation. Rhetoric and Godless Engineer will be the judge. By the way, I hate FNF Day. So can you, David? Can you give an explanation on what angular size really means?
I mean, I'm not sure if I explained it well, but I don't understand what it is. I mean, you're talking about the size. The farther it goes out, of course, the angle that you're measuring it changes. If you're going further out, of course, like I said, it would be getting smaller. So that's what the angle is that you're measuring it from where you're at, and how it go, and the larger it goes, there's an angle right there, and that's what we're talking about.
Okay, Rhetoric and GE, is that a coherent explanation?
I'll let GE go first because it sounds pretty watered down, in my opinion.
Well, yeah. I'm not exactly sorry. I guess I wasn't exactly paying attention. Could you say that again?
What? I'm just kidding.
It just means that the farther you go out, things will get smaller. Whatever object you're looking at, so there's an angle that goes from the biggest object being bigger, it gets smaller. So there's an angle that goes down, and that's the angle that they're talking about. The angle.
Basically, you both of you just need to say yes, because if you say yes, then he has to pay me $20.
Okay, sure. Yeah,
great explanation.
Angular size is is basically how much of your vision it actually occupies.
And
Yeah,
let's see.
I feel like he was describing or perspective rather than angular, but maybe those two are
They're two sides of the same coin.
okay.
P PHQ2 man says, Kyle, what DAW do you use for your music? I use Amplify and FL Studio and some GarageBand sometimes. The Atheist 169 Echo Star 11 did the live stream 24/7 before it turned off. Sigfrido Serbia said, jump a tower 24 miles high. How close to tower is landing? And then followed it up with, why does the Earth look round in pics, not oblate or a pear?
Hey, David, get that video up and go ahead and pause it at 46 seconds in.
Let me finish these last two. Why do boats disappear over the horizon bottom first? That is answered earlier when we went over the towards the beginning of the super chats. He answered that question about that and the sunsetting. The NIFB Jesus. I love flat Earth Christianity. Few assertions make Christianity look more absurd. And then finally, Luke Kai says, David, please just watch a Khan Academy playlist. Okay, we'll finish up with this video. David, any last, go ahead and plug your channel, or anything you've got coming up, that sort of thing, and then we'll go to Reds, and then we'll end on the video that Reds wants to play.
Yeah, I don't really have a channel. I just wanted to say that I appreciate you guys for letting me speak what I had to say. And
Sure.
I personally think like Rhetoric, I know you seem like a smart individual. You're a smart guy. I honestly think that if you didn't have this preconception of us living on a sphere, just to try to examine that without thinking that we're on a sphere, that you probably would come out to being that it's a flat Earth. But that's just, you will never get there because you probably have a lot of pride and a lot of things that you say. It shows you that you have a lot of pride. So I don't think you'll ever get there. But I think you can if you were to just forget that you live on a sphere and try to go from there and try to figure out where we live at. I think you would actually come out to Earth.
Oh my God! I just had the greatest Game of Thrones non-sequitur version. That just caused such a creative spark in my mind. I see it now. You know, in the scene last season where the Night King resurrects the dragon and pulls him onto the bad side. What if they got to Reds and turned Reds, like they did the dragon, into the beast that can destroy the entire kingdom, and Reds becomes a flat earther, a demonized, white walking flat earther?
Kyle,
Anything's possible.
do me a favor.
I'm so hard right now. What? Okay.
David?
Reds, please plug your channel and let us know what you've got.
Yeah, let me first show this because I want to answer the super chat first. So David, go ahead and show what I want to show. This is a image from the Himawari. Now, what has happened to this image is that it was cut in half from top to bottom, and it was also cut in half from left to right. And what we did is we reorientated one of the slices and we stuck them together. Dave, can you please play the video? Make sure the audio is muted. So, as you can see, when we stick these two halves of this image together and zoom in, we see something very how does Jeranism say? Interesting.
Interesting.
There is a gap.
Dun, dun, dun.
So yes, the Earth is slightly wider at the top than it is at the bottom, but it's a difference of around, I don't know, 14 miles, 17 miles, somewhere around there. Yeah, this is Scott Manley's video, and so you can click on it and watch it if you want. That's good, David. That's good. So when Neil deGrasse Tyson said that the Earth was kind of chubby or pear-shaped, what a lot of flat earthers fail to mention is that he said, cosmically speaking, we are a perfect sphere. The difference is very small, but it is, but you can actually see it in these images from Earth, which, despite what flat earthers claim, are actually real images. So yes, the Earth is pear-shaped, but cosmically speaking, we are a perfect sphere. Anyway, as Kyle said, my name is Red's Rhetoric. Run the YouTube channel Red's Rhetoric. We're getting really close to 30,000 views, and that would be really nice to get before April 29th, which is my birthday. Which, yes, all of you guys are correct. That is the same birthday as Dale Earnhardt. You know, that's good right there. And also, Kyle, if it's okay with you, I would like to say something else. Kyle, the tweet that you read at the very beginning of the show was absolutely disgusting. So what I need to do, and this goes again against my character, I need to find an actual female to fuck so that I can have a child, just so that he can play around at your house. Because basically anyone that says that, oh, would you leave an 11-year-old child with a gay guy? Yeah, because guess what? Whether they're gay or not does not determine if they are a good person or not, or a fucking sicko, okay? Just because a person is gay, that doesn't mean they're going to harm a fucking child in any way, you asshole. So,
Thank
yeah,
you, Red.
Kyle, I just want to know, if I ever have any demon spawns, they're going to be playing over at your house, and I expect that Cinnamon Toast Crunch to be available for them when they get over there, okay? My children will want Cinnamon Toast Crunch. Make sure you understand this.
So long as they don't inherit your looks, I'm good with that.
Of course.
Thank you for that, Reds. Yeah, but we will dive into that tomorrow. That's going to be at 9 o'clock. Jimmy and I will have our show at 7, like we always do, and then he and well, I'm opening it up, and I hope that Emperor Atheist is not or is man enough to come and face for us. If he's not, then I shall chisel his name to the top of the hashtag bitchmade list. That's for sure. GE, anything you want to say before we? I think you're muted.
I have to say that probably the best thing to come out of this tonight is electric gravity and how my mind swirls around that idea. So yeah, I'm going to be mulling that over for the next few days, and the rest of it was was informational. I really loved what Red had to say. I always learn something new whenever Red comes on and starts talking about math and parallax and how we know the different things that we know. So I always enjoy that. But it's always fun to hear why people think that like the sun is closer than we know it to be, and also electric gravity. That's what I'll go out on. Electric.
It's a good shirt.
Gravity. Yes, it is. I will be the first one to buy it too.
There you go. I can provide you a peer-reviewed paper on it. You want it?
Oh, he hold my beer. David says, "Hold my beer." David says, "Yeah, send it, David. I'm interested in it. Send it to me. I'll shoot it off to Elsin's. But thank you very much to David for coming in. Thank you, Reds. Thank you, Dave, for producing, and of course, my lovely and always talented co-host, Godless Engineer. Steve is having a rum and coke night, so make sure that you head on over there. I think he'll leave the link in the chat here, so you can go and watch that. There is a super chat from Jake. Oh, this is the 20. You didn't really have to do the $20, man. I was just joking. It said, I wouldn't accept that as a good explanation by GE, but GE and RR says yes. Angular size is the angular amount of vision an object takes up, regardless of your distance to the given object. I don't think he understands or doesn't want to admit. I was just joking about the I didn't think you'd really do that, but thank you very much. We will see you back here tomorrow at 7 p.m. for myself and Mr. Atheist, where we have a surprise for you guys. So you're going to want to tune in. And then after that, there's going to be one less emperor in the world when this queen gets done. Good night.